Modern developers are now integrating thousands of lines of machine-generated code into their environments in seconds. This is a high-velocity stream of logic built on the fly by large language models. But these models are predictive text engines. They don't actually understand your specific codebase. They frequently invent variables, conjure up objects, and call methods that simply do not exist in your files. If you drop that generated output straight into plain JavaScript, the language won't stop it. JavaScript's dynamic architecture assumes the developer is correct, accepting fabricated inputs without any internal verification. That hallucinated code stays dormant until a user interacts with it. A single click calls the non-existent method, and the system collapses at runtime. Allowing a machine to write your logic means you become the primary guarantor of its accuracy. In a modern AI-first workflow, shipping unverified JavaScript means you are assuming total responsibility for every hallucination the model produces. To manage this risk, you have to route that intake stream through a rigid verification pipeline. The TypeScript compiler functions as a specialized hallucination filter. By explicitly defining the exact shape of your data, what a user object must look like, or what a function returns, the compiler analyzes the AI's output against those parameters. If the AI hallucinates a method that doesn't exist on a primitive string, the compiler hard stops the build process. Eliminating code execution at the compile time stage ensures that the AI's structural errors never reach your production environment. That protects your internal logic, but applications also pull in external modules and data payloads dynamically at the boundaries. If an AI suggests a dynamic import to fetch an external JSON payload, it creates a blind spot. You are pulling unpredictable data directly into your acted application logic. To secure this perimeter, you can use import attributes to lock down those dynamic requests. By appending a type attribute to the import, you force strict validation onto the incoming payload, rejecting mismatched data structures before they ever enter your system. Import attributes convert an open-ended dynamic request into a strictly validated exchange, ensuring that only the specific data you expect is allowed to pass through the port. You might assume that wrapping your code in these security filters creates a bloated application that runs slower in the browser. This ignores the concept of type erasure, the mechanism that allows for high security without a performance penalty. During the build process, every type annotation and structural check is stripped away. This verification logic never actually reaches the browser. This process gives you the structural security of a compiled language during development, while maintaining the raw execution speed of plain JavaScript for the user. This is the modern pipeline. It flows from machine-assisted intake through automated verification to clean browser execution. The AI rapidly generates the boilerplate. TypeScript serves as the automated auditor. The browser executes the verified code. In 2026, the core competency of a senior developer is no longer manually writing every line of code. It is architecting these systems of secure ingestion. Treating this infrastructure as optional is like trusting a machine to build the road while you drive blindfolded. If you don't check the AI's work at the compiler level, the runtime failure is yours to own.